You already know how to do this. You may have forgotten the words, but I know you learned them at some point. Okay, so triangles can be classified using angles and sides. So each triangle can be classified two ways, once by using angles and once by using sides. All right, so let's start with the by angles. Okay, so classifying by angles. So there are 3 different words that you can use to classify a triangle by angles, and each triangle is going to fit into one of these. So once I start telling you them, you'll remember all the other ones. Or do you know before I even tell you? You'll know when I say it. So the first way is going to be acute. You can have an acute triangle if acute triangles. Does anybody remember what those have to have? What must an acute triangle have? You don't remember? That's okay, I'll tell you.
They have to be under 90 degrees.
Yes, all 3. All 3 angles measure less than 90. Exactly. Okay, all 3 of them less than 90. So if you want to draw a little picture, there you go. There could be an acute triangle. All 3 less than 90. Then you have another option, right triangles. What must these have?
They add up to exactly 90 degrees.
Good guess, but not quite. It's that one of the angles is exactly 90. So has one angle that equals 90 degrees. So one angle is a perfect 90-degree angle. So you might have a picture might look something like this, where one of those angles really is 90. And the last one, what's your third choice?
Obtuse.
Yes, an obtuse triangle, of course. Obtuse triangle. What's the deal with them?
They're bigger than 90 degrees.
All of them?
No.
Just one. Yes.
Okay.
Has one angle greater than 90. So I want to actually take a look at that real quick. So let's just draw an obtuse triangle. Might look something like that. Where you have, let me do that again. I'm going to make it even bigger.
Out of the bathroom.
Go so fast. Okay, so I want to investigate that real quick. Just what we're talking about here. Let me get some of my thingamajiggies. I get some of the smaller size ones that are down at the bottom here. Let's do a yellow, a green, and a red. Oh, like a stop sign. Okay, so let's check this out. Here I have 3 sides, obviously, making up a triangle, okay? Now, So this I would claim is probably an acute triangle. That one looks a little bit smaller than 90, and these are definitely smaller than 90. So I'm pretty sure that one's going to be an acute triangle. Now, as far as a right triangle goes, if I had a right angle in here, so let me make the red and the yellow 90 degrees with each other. Is it possible to have a second 90-degree angle in the same triangle? Well, let's say I made the green and the yellow 90 degrees. Is there any way, if these two are 90-degree angles, could this shape be a triangle? I say no. Even if you connect these two, you don't have a triangle now. Now you have some quadrilateral, right? So I can't see a way that I could have a shape that has two 90-degree angles and it's a single triangle. That's impossible, right? There would be no way, because if I have two 90s, the smallest thing this could be is a four-sided figure. There's no way it could be a triangle, right? So the best I can do, if I have a 90-degree angle, like I do here, I can only have the one, right? I could never have two 90-degree angles in one triangle. That's what I'm getting at here. It's impossible. Let's talk about the obtuse angles now. So if I had, here's one angle of my triangle that's clearly obtuse, right? And let's just say I tried to do the same thing. I tried to have a second angle that was obtuse. So if I came over here and I made another obtuse angle between the green and the purple here, so that angle's obtuse, and so is this. Is there any way that this shape could possibly be a triangle, leaving those two angles as obtuse? No. Again, I'd be back to this four-sided figure. So it's impossible for me to have two obtuse angles in one triangle. I can have one, right? I can have that one, and then I just connect this third side. That's fine. But notice how the other two have to be acute. Right? These two are going to have to be little ones. Could I have, think about this. Could you have an obtuse and a right? Is that possible? In one triangle, could you have an obtuse angle and a right angle and have it still be a triangle?
Maybe.
Well, let's try
No.
it. So let's make the purple and the green have a 90-degree angle. So that looks pretty close to 90. And this one's obtuse. Even if I made it less obtuse, right? There's less obtuse, but there's no way I'd be able to, this has to swing this way to be acute. Right? Do you see that? Or actually, maybe it's better if I leave this as the 90 and then this can swing over. Right? That's the only way. So if one of my angles is 90, the other two have to be acute. So if I tried to do a 90-degree and an obtuse, it's impossible. It's never going to come back to be one triangle. It would have to be a four-sided figure. Okay, so that's good to know. So this is really my three options. I can have all three of them or something less than 90. I can have one that's 90, and that means that the other two would be acute, or I can have one that's obtuse and the other two are acute. I can't really, I can't mix the right and obtuse angles in one triangle. Okay, does all this make sense? I'll take that as, okay, good. I have a yes. So there's classifying by angles. Now let's go ahead and classify by sides. These are the funny words that you probably remember from way back when. Anybody remember any of them? There's one for a triangle that has all three sides, different lengths. Do you remember what that's called?
Miss Davey, I'll be right back.
What'd you say?
I'll be right back. I have to run and do something real quick.
Oh my gosh.
It'll be like 1 minute.
Ah,
I'll be right
I don't
back.
really know how to respond.
No, someone's at the door and my mom's not home, so I have to go like.
Well, hurry.
I will.
Make
I'll
sure
be
it's
right
not
back.
an intruder. I wouldn't know how to handle that situation. Gosh. Anyway, classifying by sides. I'm looking for the word that describes a triangle that has all three side lengths as different measures. Starts with an S. Anybody remember?
Supplementary.
Good guess, but no. The word I'm looking for is scalene. Do you remember hearing that word from somewhere?
Yes.
Yes, scalene. Okay. This is a triangle with all three sides different lengths. So actually, I'm going to write no equal sides. So these little sticks that I have, each color is the same length. So this one would be a scalene triangle because I have none of my colors are the same here. I've got yellow, green, and purple. So none are the same. That one is called scalene. All three sides are different lengths. So one way that you could show that, notice this has nothing to do with the angles. The angles could be whatever. I could have a scalene triangle that's also obtuse. I could have a scalene triangle that's also acute. So one way that I can show you that all three sides are different lengths, well, you have two ways. I can actually put measurements, like I could say this is 3 inches, 4 inches, 5 inches, or you can mark them with different slashes. So if you see that, if I put a 1/2/3 slashes, that indicates to you that all three of those are different lengths. I don't know what they are, but none of them are the same. Okay, so you remember scalene. Maybe you remember the word for the next one that has two sides the same. Anybody recall? What's the name of the triangle that has two sides the same? Starts with an I. That helps.
Isosceles?
Yes! Isosceles. Note how you spell it. ISOSCELES. Isosceles. So this one is a triangle with two equal sides. Okay, so if I want to draw a picture, I can use sort of that same idea with the slashes. So since I want two of them to be the same, I'm going to mark two of them with just one slash. And then the third one, I'll put two slashes on it to show that I have two others that are the same and one that's different. Here they are with my cool little sticks. So I have two purples, so you know that the two purples are the same, and then the yellow is different. Now, don't think that all isosceles triangles look like this, because they don't. Sometimes they'll be like this. So it's not always this two that are the same are the ones that are like here. That could be wherever, right? Could be anywhere. So isosceles, two sides the same. And anybody know the word for when all three sides are the same?
Equilateral.
is, look at you. Equilateral, which is a nice word because it has the word equal right in it. Equilateral. Triangle with all three sides equal. Okay, so equilateral triangles are going to look like that. All three sides are going to be the same, and they always kind of look like that. I'll show you with my little sticks here. I just got to get out the purple. Ta-da! There they are. Equilateral triangles are so nice. There's so many cool things about them. We'll be talking. This is a thing that you might not know. You might have thought that, you knew everything that there was to know about triangles. Turns out you don't. There's I could teach an entire course on just triangles. That's how much stuff is in there. So interesting, right? You're thinking it's three sides. It's not that hard. No, it's not that it's hard. It's just that there's actually way more than meets the eye. Any hoosers. All right. So when I go to classify a triangle, I'm always going to give it two names. I'm going to give it one of the names up top for the angle. So it's either going to be acute, right, or obtuse. And then it's also going to be one of these at the bottom. So every triangle, you can pick one from each category. All right. It can't ever be two from one category because that wouldn't really make, well, actually, I take that back. It kind of can. Because there's if you want to get real technical, isosceles, the definition really is a triangle with at least two equal sides. So you could call technically an equilateral triangle an isosceles triangle, but you never would because that's not your most descriptive term. So I guess one triangle could fit into both of those, but that's an exception there. Okay, so now let's take a look at a couple of triangles and we'll just classify them, okay? Okay, so let me draw you a couple. Classify the following. Ethan, are you back?
Yeah.
Oh, thank goodness. I just want to make sure you're safe.
I'm good.
Oh, good. That was you, right? That had to go to the door?
Yeah, that was me.
Okay. It doesn't always pop. I got to look at this other screen. Yeah, that's right. I got to look over here for your faces. So if I'm just looking here, I don't know who's talking. All right. Anywho, so let's try this. All right, so here are 4 different triangles. I want to name them once from each category. So by angles and by sides. Okay, so the first one, if you classify this by angles, remember you're choosing between acute, right, or obtuse. This one's clearly got to be a what?
Right.
Right. Yes, it has a right angle. And again, make sure that you are not assuming that it's right angles. I have to either mark it as one or something has to tell you. You can't just look at it and assume that it's like this one right here, number 4. Maybe that's a right angle. Maybe it's not. You can't assume that it is. Okay, so anyway, this one has a little right angle mark, so it's going to be a right, and then we're going to classify it by side. So is it scalene, isosceles, or equilateral? Come on, people. I know you know.
What number are we doing?
1.
1.
Yeah. It's a right. So I'm looking for if it's a,
It's a right isosceles.
is it?
No? Maybe? I don't know. Hang on.
I got one answer in the chat. Look at the 3 side lengths, 3, 4, and 5. None of them are the same.
Oh, it's scalene.
Scalene. That's the one. So this triangle would be fully classified as a right scalene. Okay. Number 2. Now you'll notice I've marked all 3 sides the same. I didn't put anything in on the angles. So here's, we're going to learn this eventually, but if the 3 sides are the same, guess what that means about the angles? The angles are all automatically the same as well. Isn't that neat? So the only option for an equilateral triangle is to have 3 equal angles that are all 60 degrees. So these are all 60s, which means that this thing is going to be an, if you classify by angle, it would be
Equilateral.
equilateral is for the sides, but for the angles out of acute, right, or obtuse, we're going to go with acute, right?
Acute.
So it would be an acute equilateral. There is a, if you ever see this, if you do have all 3 angles the same, there is another word that you can use instead of acute. It's equiangular. Isn't that fancy? Equiangular. So because acute just means all of them have to be less than 90. If they happen to all be the same, you can use that word equiangular. So I'll even put that, or equiangular equilateral. That's kind of neat. So all 3 angles are the same, equiangular. All right. Number 3. This thing has a 91-degree angle, so it must be by angle. This would be an
Obtuse.
obtuse. And then based on the markings on the side,
Scalene.
it would be scalene. Yep. Perfect. And then this last one. Now, this one, I left this a little ambiguous, so I'm going to have to tell you what this is. Let's make that a right angle. So I'm going to come in and make it right. So now, obviously, it's a right. A right what, though?
Scalene.
Scalene. Now, what I want you to try, I want you to draw the following. If possible. I want you to draw me an isosceles right triangle. I want you to draw for me an isosceles obtuse triangle. And let's go with an obtuse equilateral. Try and draw for me these 3 triangles, please. Just do a little sketch. And isosceles, remember, means that 2 sides are the same. So make sure that in your diagram, you are either marking them the same with those little congruence marks, those slashes, or you could actually put numbers. So you could say like 2 sides are both 4 inches and then the other side is 5 inches or whatever. Oops. Okay, number one, can you draw an isosceles right triangle? Is it possible?
Yes.
Yes, it's gonna look something like this. You obviously need a right angle in there. Jeez. I can't wait to get a new pack of pens. What is up with this one? All right, so you're gonna have a right angle in there somewhere. And then those two sides are gonna be the ones that are the same. And then you're gonna have that third side like that. So that's kind of all isosceles right triangles basically look the same. What you can't have, this is impossible. If you had your right angle here, you could never have these two sides be the sides that are the same. That's impossible. So if you actually, I wish you guys had all these kits that I have, these thingies. They're called Exploragons. You could ask for them as a stocking stuffer. So you could do what I do. But so I'm going to cross this out because that's impossible. So if I took two that were the same, so let me just take two greens, right? So if I actually tried to make this diagram in real life, there's two that are the same. And I want the right angle to be over here. So let me let's make this one the right angle with the pink side that's different. Okay, so see how it doesn't reach? That side across from the 90, the hypotenuse, if you remember that word, always has to be the longest side. So there's no way that these two sides could be the same and that this is able to reach over there. So that is an impossible diagram right there. So if you have an isosceles right triangle, it has to look like that one. Isn't that interesting? Gosh, I love triangles. Okay, isosceles obtuse triangle. Is that possible? Is it possible to draw an obtuse isosceles triangle? Someone tell me, is it possible? Yes or no?
Yes.
Yes, it is. And I will show you here's one that I made. So you have an obtuse angle down here, and then I have two sides that are the same, and then one that is not. So they're all going to look kind of like that. So I'd have oh, that's not a very good one. I'd have my big old obtuse angle there, and it's these two sides that would have to be the same. And then they're going to be connected by some third side. How about an obtuse equilateral? Is that possible?
Yes.
It is?
Well, I mean, not technically, but you could probably try it.
We try. So here's one that has all three sides the same. There's no way that one of these angles could be obtuse and it be a triangle, right? So here's my obtuse angle. If these three sides really are going to be the same length, this one's never going to reach, right? It would never be able to get there if I'm keeping all three sides the same. Yeah, equilateral triangles have to be acute. That's the only way it works. So they're all going to look just like that. I don't have any other option. So obtuse equilateral, impossible. Impossible. Okay, so that's all that I had to teach you. I am going to show you just a tiny snapshot of your homework, which is on Delta Math. Because the one part is a little bit different. So let me just shut this camera off. Any questions so far? Oh, someone logged off. What are they doing? Okay, classifying triangles. Let me share the screen real quick. This is probably a pretty brief assignment for you guys. All right, so here you're just going to pick from the choices below which one fits here. So if I take a look, notice I have two sides that are the same, 5.66. So I definitely want isosceles in my choices. So I can either choose isosceles acute, isosceles obtuse, or isosceles right. And then if you look at the angles, I do have a 90. So this one's just going to be an isosceles right. I'm sorry that they're not doing it as right isosceles. It should be the angle first and then the sides, but I mean, it doesn't really matter. But anyway, so there's that. But then, so you have a couple of those to do. But then look at this next section. This is so cool. You get to draw them right on here. So these yellow dots, you can click on them and move them. So they want you to make an equilateral triangle here. So you're just going to take the yellow dot and move it until you get, I need all three sides to be the same. So you're just going to move, or I could just focus on the angles. They all have to be 60. Ooh, I just missed it. This one's probably going to be kind of annoying. Sorry. This particular problem anyway. Oh, there's a 60. I just got to move this one. Woo, so close. Oh, there it is. I got it. Okay, an isosceles obtuse. So that should be a little bit easier. I already have the obtuse angles. So let me just make this side be the 5.39. Perfect. So that one's a little bit easier. All right, so you just grab the yellow dot and move it until it, oh, isosceles obtuse. What did I have? I have that right. That's obtuse. Oh, look at my, oh, that is annoying. These two angles should be the same and they're not. Oh, I don't like that at all. There we go. Oh, no. There we go. I'm sorry. I didn't realize it was that finicky. But anyway, any questions on this, guys? We're okay? All right, so go ahead and try these. I'm going to